So the population proportion is the proportion of US adults who think healthy children should be required to be vaccinated. Some researchers making a claim that that proportion is greater than 0.8. So we collected a sample, 200 observations, 200 adults. 82% of them responded that healthy children should be required to be vaccinated. First off, is the condition satisfied? N times P. 164, yes. And N times Q naturally would be 36.
Wait, where did you get 84 from?
Oh, 82. Okay. So N times P is greater than 5, N times Q is greater than 5. So we can use the test. So the claim that is made is P is greater than 0.8. Where should this statement go?
Alternative.
Alternative, why?
There's no equals.
No equal sign. If that is P greater than 0.8, what is this?
Less than or equal to.
So what type of test are we about to perform? Right. Big alpha was 0.5. So we're about to perform a right tail test with alpha as 0.5. The test statistic is P hat minus P over square root of P times Q divided by N. P hat is given in the problem. Can you tell me what that is? 82%, so 0.82. The claim is 0.8. So the most common mistake is using 0.82 instead of 0.8. Now, it is a common mistake because most textbooks would go for using the reference value. But there is another test where one can use P hat instead of P naught. We won't get into that. So as far as this class is concerned, we're using 0.8, not 0.82. The calculator will also be using 0.8. We'll find out. What is that value?
0.707.
0.707. Where should the rejection region be? Left hand side, right hand, well, left hand side, right hand side, both sides.
Right.
Right. what would that area equal to?
Alpha.
Alpha, which is 0.25. And how do we find that number? Inverse norm. Good. So that is our rejection region. Where does the tested distance fall? 0.707. Perhaps there. Did the tested distance fall in the rejection region? No. Should we reject the null? No. So our conclusion is to not reject the null. Did we find sufficient evidence to work the claim? Jared,
What?
did we find sufficient evidence to work the claim?
Sure,
Sure. Oh,
we did it.
no, we did not find sufficient evidence to work the claim because we did not reject the null. So we cannot say that there is enough evidence to support the claim. Well, yes,
Where do we use the normal CDF?
patience, I'm guessing.
Um,
So when we first started, the sample proportion was 82%, which is 0.82. The researcher's claim is that P is bigger than 0.8. Is 0.82 bigger than 0.8? Yes or no? Yes, but we did not agree to the researcher's claim. Why? Do you follow my question?
because it's just the same.
Because it is based on one sample and we have to account for randomness. This is a right tail test. And what do we know about the p-value for a right tail test? It is the area above
Or sorry,
the tested distance.
yeah.
Even before you start the problem or put that or try to find that area, do we expect that area to be bigger than 5% or less than 5%?
Are you talking about the rejection area?
No, the probability of p-value.
Bigger.
Bigger. So above the test statistic over here, the area in blue will be the p-value. Naturally, the p-value is bigger than alpha, but how do we find that probability? Normal CDF, where should we start?
0.707.
0.707, where to end? And what is that value?
0.239.
Exactly.
You can do 0.240.
So the maximum amount of, or the maximum probability of typo error in rejecting the null has to be 5%. The data is telling me if I rejected the null, based on the information that I have, and I went with the claim, the probability that I'd be making a mistake is 24%. Should you make a conclusion knowing that the probability of error would be 24%? No, doesn't look smart if you did. Are we clear?